Parametric equations. Points of intersection. Points A, B and C lie on the curve with these parametric equations. Point C has a y-coordinate that's equal to 0. So we substitute in here y equals 0. We divide by a on each side. Take the 8 to the other side, so t cubed equals minus 8, and then cube root. Now x is equal to minus 4 for this point, so x is minus 4. T is equal to minus 2 for this point. Every single point on the curve has a unique t value. And if we substitute into the equation for x, so minus 4 a t squared plus t, solve to work out a. So now we know the value of a both here and here. For points A and B, x is equal to 0. So if you put x equals 0 in here, we already know the value of a. And then solve, factorizing, so t equals 0 or t equals 2. So if we're moving along the curve in this direction, t equals minus 2, the next point will be t equals 0 here, and then point B will be t equals 2. So we have the parameter value for all of these 3 points. Using these two t values, if we substitute, we can work out the y-coordinates for these 2 points, for A and B. So t equals 0, so if you put 0 in here, then you've got 8 times minus a half, minus 4, and when t equals 2, 2 cubed is 8, plus 8, 16 times minus a half, minus 8. So now we have the coordinates for points A and B. In this example, we have a curve given in terms of these parametric equations, and the curve will intersect a line given in Cartesian form. So when we solve these equations together, we will work out the value of the parameter for each point of intersection, and then the parameter can be substituted back into here to work out the x and y coordinates for any point or points of intersection. Okay, so first step, x is t squared here, and y is 4t here, and then we've got plus 4 there equals 0. So we have an equation all in terms of t, and we solve to get t equals minus 2. So now we're going to substitute this value into x and y to work out the coordinates of the point of intersection. There is a single point of intersection because we only have a single value for the parameter t. So substituting in gives us this point as the point of intersection. So we have this curve with points A and B given in terms of these parametric equations for these values of t. The parameter t is in this interval. So what can we find out about points A and B? What are their coordinates? What's the value of the parameter at these points? So we know that x is equal to 0 at these 2 points. So x equals 0 for that equation, like so. And if I divide this equation throughout by cos t, 0 divided by anything is 0. Cos t divided by cos t, anything divided by itself is 1, and sine over cos is tan. So I can rearrange this to say that tan t is equal to minus 1. So tan inverse of minus 1, calculator in radians mode, gives us t is equal to minus a quarter pi. The t there is an angle, and the angle that we've worked out from tan inverse of -1 is -1/4 pi. If we substitute that value into here for x and into this equation for y, we get the coordinates. Another angle for the solution of this equation comes from adding pi to the original angle. By adding pi and getting this new value of t, we must check to make sure it's within this interval. If it's not, it needs to be discarded, and we need to search for other values that are within this interval. And then again, substituting this angle or this value of t into the equation for x and the equation for y gives us this point. They both have the same x coordinate, but the y coordinate here is greater than the y coordinate here, so this point must be B because it's above point A. It has a greater y coordinate than A does. For practice, try these questions.